So hello everyone, and it's an honor to be here to talk with you guys. So my talk title will be Talk with Your Data, the application development in the area of large language model. So first is, who am I? Okay. So my name is Pascal. I was being a developer for like 5 years and deliver several products globally, and I'm happy with that. And then you see the AI and the machine learning concept comes, and I say, okay, I don't understand it. So I go back to the uni and started my PhD back in 2022. Now I'm in middle range of it. So wait a minute. Currently, I'm a researcher at the UWA's natural language and the technical language processing groups at the UWA. So for the talk, we have 3 keywords here today. The first one is large language model, and then is data, and application development. What is large language model? I'm sure everyone already know that. Everyone uses ChatGPT probably, and the GitHub Copilot. That's closed-sourced large language models, probably the best on the market. And then Meta, probably they love the open source community so much, so they released the Llama and the Llama 2. And then there is a cluster of all the open source, the large language models on the market, and it's getting better and better. So basically, for the large language model, when we're talking about the closed source one, like the GPT-1, OpenAI 1, it's normally have better performance regarding the accuracy. But for some companies, we wanted to get a better controllability and protect our privacy. So some of them may probably using the self-hosted open source large language model. So when it comes, it's already been 1 year and more, so it's kind of bring a lot of opportunities there, and probably a stone will come in the front. So I think the opportunity, some people are listed as 5 types of them. Like the ChatGPT is a conversational agent, then GitHub Copilot, and you probably heard about the LangChain, and it's actually overturned our research areas, like the normally NLP tasks is totally being changed, how you do the job. And the last one is the one I will talk about today, is RAG. I'm not sure how much of you understand, like heard the concept of the RAGs. It's actually pretty simple. I will talk about it later. First, we will talk about 2 main problems large language model has. So the first problem is data hallucination, which is like a large language model is a probability model, so it will make up some facts probably in another universe, but not in our universe. So that will cause trouble, right? And probably significant troubles later in the production. And the second problem is if your model is training last night and you ask him something about the latency 2024 today, then it cannot answer it. It needs to go to the LinkedIn or the Twitter to search for the text and they answer your question. So what I just mentioned is going to the LinkedIn or going to the Twitter to search for the 2024 latency tags. That's actually called a RAG. So the first step is retrieval of the relevant information, augment your prompt. Basically, just add the things you have searched out and put it in the prompt, and then generate the result. It sounds very simple, but I think the first line of the description there, retrieval of the relevant information, is probably will bring the stone to the serverless architecture or the microservice architecture later, because that's naturally suited there for them. So our first keyword in the title is data. So where the data will stay, this is based on the DB engines, like 70-some% of the data actually in the relational database. And it's quite stable across the past 10 years. Only the graph DB can attract more attention in recent years because we are in a very, very complex world. So about your data, where is your data? If you are companies, your data probably sit into the PDF reports, your Excels, your documentations, or possibly your database. And actually, in my opinion, they can all be sorted and put back into a relational database, right? So our application development ideas goal will become, I'd like to automate the whole process, extracting the answers from my data sources for my business queries. Basically, I want to get the business analytics copilot. Then the question come up is how? From the pipeline perspective, it's actually pretty simple. You get a business query, which is natural language text, and you send it to the large language model, like what you send it to your business analytics team, and ask them to translate it into the SQL. You send it to the database and run the query. If it's wrong, then okay, we go back, fix the SQL query you're writing, and then do it again until you get the right data from your database. and then you interrupt it or understand it, get an answer for your boss. Say, like last quarter, you probably get more profit. And the second type of application is like you're probably being asked for a report. Like in WA, we are so big, so we probably wanted to get a report as a map. That looks even simpler in this pipeline perspective. So text to the SQL, and then it's run it again and get the correct answer. Then it's generated a map for you. But I think the question comes out, can large language model do the text to SQL part in a good manner? So we need to divide it by the scenarios. So the first scenario is if you have a single tables and it have limited data, you basically can prompt with all of the data, and it give you the answer. But that's what the research community is actually doing. But that's not realistic. Because in this way, like I handle one database, one table with 1 billion records. How could you do that? And it's not cost efficient. So more realistic are the second two scenarios. First is you're trying to handle with one big table. You probably want to write a SQL query just for this specific table. So you probably can put it in a prompt with the structure information of that table, like the column names and the unique values for each text field, and the static distribution for the value field, right? So that's one of the examples we can handle with and start with. Then the second scenario is the one we actually aiming for, is if we have multiple tables within a database, we want to, if we have a query coming, we want to identify the relevant tables. And then we feed the table's information into the prompt, and then want it to get the proper SQL queries out and generate the result. So will that work? This is a demo for the first scenario I was talking about, talk with one table. So I get some data from the WA Police website. Hopefully that's legal. And the data actually is pretty simple. It has the financial year information, crime type information, and for each month, each type, how many crimes actually happened there. So I combine with geology information, all the things. So here is when I put it in the prompt about how many the suburbs actually in the Perth area, and how many crime types, and then tell it about all the columns it has, and ask the question. You can see it's doing pretty well. Like in the past 5 years, which suburb get the most crimes? Of course, it's Perth, right? And you ask it to explain it to you. It will give you something makes sense. So in this scenario, it's actually I tried different talks. For the model accuracy performance, actually pretty good. Like 90% of it, it can give you the correct answer. So for the second scenario, when you want to talk with multiple tables or your entire database, will that work? So this is actually a map, what I'm talking about, generated by the way I just mentioned. So the data behind this is ABS 2021 data, and I pour them together and put it in a relational database with 74 tables, and each table will have their columns, and because they have the metadata about this or tables information in the ABS, like they have the topics and which area is related to. So you probably will think about we repeat what we have done with this one. We just dump the database schemas to the prompt and waiting it to generate the SQL for you. I tried that way. It's actually not that good in the performance because you dump too much irrelevant information to it. So before I go to put the prompt to the large language model, I actually generated a graph, a knowledge graph for the whole database schema. So I have the table as nodes, have the topic as nodes, and have their columns, like unique values as nodes, connect them together. And then you probably already heard about that concept called embedding, which is the large language model run behind with. Like that's another known story, but my interruption is the embedding is another way as an index of the database. So you want to search the information from that. So what I'm doing is I get all of the text information into embedding, and then I use similarity search to get the relevant loads it has, and run the shortest path in the graph, and do a voting, say, okay, which tables are actually showing up in this kind of shortest path. I rank the top 5, I treat them as relevant tables, and feed them with the structure they have to the prompt and generate the result. It's actually come back pretty good. I also give an example how you generate the map. If you don't give it, it cannot do that. So that's one of the map is generating. It's basically saying like in the near the Swan River, there is less people was pretty stressed with a mortgage, but far away from the Swan River, there is more people stressed with the mortgage back in the 2021. And there is a list of the reports actually I was generated why this way there, so you can check it. So I think the next question is like, looks good, but whether that's production ready, because what I'm showing you is just some screenshots. So when it's going to the production, what will it look like? That's actually the key question, because when people asking, with our research, I find when I ask other people about what's your performance, research people will always interrupt is at left side. What's your model accuracy? I will say 80% or 70%. And, but when it's going to the developers as us here, you're probably asking for actually is the latency. How long will it take to give you the result? For the model accuracy one, for talk with one tables, I think it's nearly production ready, like 90% based on your scenarios. You can tweak your prompt with that way. For multiple tables within a database, you probably can get the accuracy to 80%. But for the latency, I don't think it's production ready. The back, like behind this chatbot is a GPT-4. I also tried others, but GPT-4 get the best result. However, each round of the chat, it will take the GPT-4 around 30 seconds to give me the result. Sometimes shorter, sometimes longer. As what's Andrew Wood said, is like if it's larger than 4 seconds, your customer leave you. So in this perspective, I don't think it's really that production ready. But I think that's a question. Like I was just here to share the experiment result I have. So to get the latency better, you probably have different directions you can going forward. Like what I was just saying, for the open source large language models, you can fine tune it or get it being smaller. It can run on Raspberry Pi and get it to be faster for your specific scenarios. So this question is basically an open-ended question from my interruption. So it has something can be done, but you need to find the user scenario for it according to the current performance level it has. So as developers, we always talking about the future works. So for the map one, I actually already have the backend finished, but I haven't hooked with the chatbot. So I will plan to do that later. You probably can check with the website and send the message, ask it to generate the map report. And also for the chat response, to get it faster, to be able to production ready, I probably can stream the chat from the ChatGPT back to you guys, so that can improve the performance a bit better. But I'm not sure which level it will bring us to. But as a researcher, my future work is basically get a self-hosted large language model latency and the model performance getting better. That's the only thing we can do, because we cannot control OpenAI, right? And if you want to try, in the middle is a demo of the thing I just shown. And on the right side, I have like built an API similar to the OpenAI's API, but with some self-hosted large language models. So if you have some ideas for the product or you want to do some experiment with these open sourced ones, you can just scan this one and drop me a message. We can work it together. So you don't need to repeat it yourself going through the hard process to deploy it. And if you want to talk with me or have questions, you can connect me with LinkedIn. That's all. So thank you. Questions?
Does anybody have any questions for Pascal? I have a mic. I'll bring it to you. This is my favorite part.
All right. With the model accuracy, how do you tell when the model's failed?
So I think failed, there come to two perspectives. The first perspective is when you're doing the action, you see there, execute a SQL. It's probably don't give you the result, so it will throw an error. You need to fix the syntax of your SQL, so you know it's failed. So you can see there has a loop there. You can ask it to self-improve it. That's a concept called the AutoGPT, and it's storming last year, but I don't think much people talking about it this year because it's already been applied it. But the second thing is actually a good question. That's a very research, like a question there is, if semantically it's wrong, how do you know that? I don't think we have answers with that question in the research community. People are working towards that.
Okay, thank you.
Yeah.
Any more questions for Pascal? Oh. can you put your hands back up?
You've mentioned the accuracy of the model, say you measured 80%. I just wondering that how do you actually get that number? Because I'm just thinking, are you just asking simple true or false question, and then you just see is it answered correctly, or do you actually answer in a more of like nuanced or multidimensional way, and then you gauge it, say 50% is good enough, etc.
Yeah, so that's the things where I start with, like evaluate it just with some simple questions and see how it performs. But remember, I'm the researcher also, so I have wear that hat. So to get it systematically, I was thinking two ways. The first way is I just published this website, trying to asking people to use it so I can gather a big data of the questions so I can evaluate the results. But things doesn't turn out that way because people are not really using my website. So we're going back to another way is, because as I said, we have the graph information about the whole database. So if after you get that, you can take out some of the nodes, then you do the run through with the whole graph. Then you basically can generate a statement for the graph. All of the questions actually come back in the root to the database structure. So we use that as a basement, and then we take out some of the information out, generate the questions. So you can have a list of the questions. It can be asked by the normal people. Because everything they were asked, you already basically cover it. That's what I'm doing, trying to evaluate that. Yeah.
Thanks, Pascal. We have time for just one more question right here.
Yeah. Hey, thanks, Pascal. Quick question around training the model and the cost, because there's a limitation on how many tokens you can send in. So can you talk about the cost and a bit about the hosting? Was this predominantly on Azure because it's OpenAI, or did you use other services as well, like Cognitive Search and stuff like that?
So the whole thing I just talked about, it haven't covered the model training process. All of these are the ready-to-use models. I currently hook the GPT-4 in the background of this application. I tried others, like all the models actually being trained online, and then they will publish the weights on the Hugging Face. Then you can doing an interface with that models. So all of it is basically ready on the market that you can use. But yes, if you wanted to get the performance with the accuracy to the next level, you can either fine-tune it or you train your model by yourself. The cost of it, sorry, I don't know really. It's it depends on your situation. Like if it's an easy task, you have the QA peers, fine-tune it to reach a level you want. It will be quite a low cost. But if you want to build some models from scratch, then nobody knows how much will it cost. You need to pay for the things because that's not something everyone was doing here. Okay, that's all.
Thanks, Pascal.
Thank you.
Great.